Hello everyone, and welcome to the City of Swan CoderDojo, our first session through live streaming. So there will be a little bit of a delay, a stream delay. So you'll be able to type into the chat and interact, ask questions and that kind of thing. But there's going to be like maybe 20-something seconds of delay between you typing that in and me receiving that. Or the delay will go the other way around. You'll have a 20-second delay on the video that you're receiving of me and what I say and what I do. And the reason for that is so that the stream can still be good quality. That delay I don't think is going to be hugely problem for us. And that way you're not getting this horrible pixelated mess because I'm trying to make it instantaneous. So yeah, leave your feedback if there's any like issues with the volume or the video, the quality or anything like that. Let me know. This is the first time I'm doing this. If you're interested in how streaming works, that's something that I might do a session on in the future. Today I'm going to just do something nice and simple. We're going to do something in Scratch. We're going to make an endless runner. So feel free to type into the chat. Whenever you see me look in this direction, I'm looking at my monitor over here, which has the chat, so I can see people typing in. Oh, someone's very excited. I am also very excited. Excellent. All right. This should be a lot of fun. Because these are going to stay up on the Futures Lab YouTube channel, I'll probably be going over just some stuff that you're probably a little bit already familiar with if you're one of the ninjas who comes to the CoderDojo at City of Swan, if I've met you before. But we might end up with ninjas from other CoderDojos. We might end up with new ninjas who haven't been to a CoderDojo before. A CoderDojo is an after-school coding club, and running it as a live stream, we're probably going to have a bit more of a traditional kind of learn how to make something type workshops. So let's get stuck in. Let's make ourselves an endless runner game. So you should be seeing my screen up here. We've got Google running. Let's go to Scratch. This will run entirely in your browser if you haven't used Scratch before. You can set up an account if you want to be able to share your projects that you're making. For now, we're just going to go up here and press Create. Very nice. Now, if you're at home and you're wanting to follow along with this tutorial, then if you have two monitors, try to have the tutorial on one side and what you're working on the other. Otherwise, maybe try and have like an iPad or a laptop off to the side just so you can refer to both of them simultaneously. That's what works for me, but this is really easy going, so we should have some fun doing this. Alright, so first of all, just again for people who haven't used Scratch before, the way that this works is, well, first of all we have sprites over here, just where I'm wiggling my mouse right now. You can make new sprites by clicking here. If we go choose sprite, we can add a sprite like this apple, and now we have these two different sprites here. We always start off with the Scratch cat, and then we could keep adding more if we wanted by going choose more sprites. If we want to get rid of sprites, then we press this little cross over a trash can symbol here, and now you can see the arrow's gone away. The other thing that we can do is we can draw sprites, and you've got here some various painting tools that you can use. I can help you to do various shapes and that kind of thing. In fact, we're going to be using a bit of this today. But for now, Let's delete these sprites. So we've got no sprites. Oh dear. This is Jin. Hopefully he doesn't interrupt the session too much. Off you go, Jin. Okay, so let's try painting ourselves a new sprite. So I'm already there at the moment. So we will get, but if you're not, then we just go to here to paint a new sprite. Oh yeah, there we go. And then what we're going to do is make a very simple block. This is going to be, and then once we make this very simple block, you can change the fill of this block by changing the color here. And you can change the outline of the block by changing the color here. So this block is actually going to be how we make our platforms in our Endless Runner game. Okay. Oh, Amy! How's it going, Amy? What am I typing for? You can hear me. It's going to take a bit of getting used to this. Alright. So, we can make this little block here. And can you see when you move this block around, there's a little cross in the middle of the block. And when you move it around, and you get close to that kind of crosshairs in the center of your screen, or the center of the drawing area, I should say, it will snap in, and then your block will be perfectly centered, which is kind of important, because if you make the objects spin, they will always spin around their center. So if your object is sort of off-centered, when it spins, it will let's say your block is like this, but the center is here, the block will kind of go, oh, like this. Instead of, if it was nice and centered, it would spin nicely like this. So this is just good practice for when you do when you make Scratch graphics. So we've got our block here. Now I'm going to show you a bit of the coding. So up here where I'm wiggling my mouse, there's the costumes where you can do the painting, and there's the coding here. Now code is generally broken down into different colors, and what we're going to do is we're going to do some simple code for a character that allows us to make them jump. So first things first, we've got our block, just our simple block. We're going to make it so that this block here can just do a jump. So what we're going to do is, let's start off simple. So we'll probably want to change this a little bit, but let's start this off simple. Okay, so we're going to go to events here, and we're going to get this when space key pressed. And then when we've got that, we're going to go to control, this sort of orange one here. We're going to grab a repeat. And then we're going to get, we're going to go to motion here. And we're going to get a change Y by 10. Okay, so in Scratch, X, if you change X, it changes the left and right, the horizontal movement on a sprite, left and right like this. And if you change the Y, it changes the up and down movement. So if you change the X by like saying change it by 10, it will go in this direction, it will go right. And if you change it by, let's say, minus 10 over and over again, it will go left. So the opposite, if you make that you have plus numbers and you have minus numbers. And if you use a minus number, it goes in the opposite direction to the plus number. So if you change Y the object will go up. And if you change y by a minus number, like changing y by -10, it will come down. So this piece of code here, very simple. When the space key is pressed, repeat 10 times. So do this over and over 10 times. Change y by 10. So let's see what that does. Let's hit space. Okay, you guys should have seen the block go up. Now it happened pretty quick. That's a bit more reasonable. Now, if we wanted this to happen a little slower, what we'd need to do is we'd have to put a wait right here after the change y by 10. So let's see what that happens when we do that. Let's go to events. Let's get in fact, let's go to control. Let's get wait 1 second. Now this is going to be too slow, but let's find out what happens. Yeah, that's too slow. So what we'll do is still going. It takes 10 seconds to finish. So we can make a measurement of time that's smaller than a second. If we go 0.05 seconds. So this is a 50th of a second. Let's drag this down and hit it again. Still a bit slow. So this wait might not be needed. Let's take this wait, and we don't need this wait, so let's put it over here and it disappears. What we can do is we can make this y value, which is 10, it's moving up by 10 each of those 10 times we ask it to. Let's change that to 4 and see what happens. Alright, so now depending on various things, you might find that your block is moving a little faster or slower than mine. So feel free to change these numbers to what you want. What I'm going to do is I'm going to maybe let's try 7. Okay, that seems reasonable. Okay, now if you keep pressing, if it sort of gets lost off the end, your block, then here's a bit of code that you can always use to bring it back. So what we'll do is we'll go to motion, we'll get a go to block, we'll say go to, so these are coordinates. These coordinates are where the sprite is in this window here, the play window. So right in the middle, right here, where my mouse is, that is 0, 0. X is 0 and Y is 0. And if it's higher than that, then the Y all the way at the top is 180. And if it was like halfway, like here, it'd be about 90. So, for example, let's make this block go to these coordinates. And the coordinates we're going to put in are, let's say, minus 100 x and 100 y. So if we want this particular line of code to run, the go to x minus 100 y 100, you can just double click on the blue line. And you can see it moved. So if I moved it away, it goes there. So if your block ever gets a bit lost off the edge of the screen and you need to bring it back, then what you can do is just grab one of these blocks here, the go to x, and just say go to 0, 0, and double click. There's another way you can do that. You can put it just here, these coordinates here. But the reason I wanted to show you this way, using this block of code, is that this will be useful because you can make your code do this at various points. You might want sprites to go to a certain place when certain events happen. Alright, so we have a simple block, and that block jumps. Okay, so with an endless runner, what I'll do is I'll show you one that I've made already. This one, I'll bring it over here. If we hit go, so you can jump, there are platforms, there are things to collect, and there are spikes that you can run into that kill you. And if you fall down, you die. And I reckon the way that I've done this, we can probably improve on as well. But one thing that we need to work is we need gravity to work. So let's get rid of that for now. Because this block, if this block is our character, needs to always be falling, because that's how gravity works. So we need something to always be happening. So what we do is we go to events here. We grab this line here when the green flag clicked. That means that this will start when the game starts. What we're going to do then is we're going to get a forever loop. So here in the, if we go to control, we grab this forever loop here. We go up to motion. Now, if this change y, by 7 makes the block go up, then how do we make it fall down? 10 points to if you shout it at your computer screen right now. I'll know. You'll have the points. What we do is we make it minus number instead of a plus number. So let's say -3. And let's hit go. See how fast we fall. So now the characters are always falling. Okay, that's interesting. And you can play with the speed of this. So you could say change y by -5. See how that works. Okay, falling a bit faster now. Alright, so what we need to do now is we need to make some other blocks that our main character block is going to be able to land on. Alright, so first of all, this sprite one here. For now, this is going to be our main character. So we can call this player, or we can call it hero, or something like that. And what we're going to do is we're going to paint a new block. So we're going to go here to the bottom right corner. We're going to go up to where it says paint. And I'll make this a different color. Why not? Let's make it blue. Sure. And I'll make it a more or less block, more or less square. Okay. There we go. It's whoops. Let's delete you. Yeah, there we go. Now if you want to grab your block and move it around, then you can go to select here, click your block and drag it around. Remember, make it nice and locked onto the center there. Whoop! Down you go, kitten. Okay, so that's good. We're going to call this purple blue block platform. And you can name your block right here, where I've got the mouse. Can everyone see my mouse, by the way? I'm hoping I'm not wiggling around nothing. Can't quite see on the feedback screen I've got over here, but we'll get some feedback later. Okay, so let's go back to the code here. So the way this is going to work is I'm just going to bring over my original game here, and what what I'm going to do is just play it. Now, can you see that these grey blocks here are, and then there's some grey spikes as well. We're landing on them, and it looks like there's a long sort of stream of them. They're actually made up of all these individual blocks. So what we're going to do is we're going to, and just here, the platform code is our platform sprite. And you can see it's just one individual block. So what we're going to do is we're going to program this one individual block to make lots of clones of itself. And then they will be strung together to look like it's one platform. And this is how a lot of code works. You have lots of very large objects like levels in, let's say, a Mario game that were made up of lots of smaller objects. And each of these smaller objects will be duplicated across, because it's very easy and very efficient to take one little block of ground and draw it lots of times, and Mario knows how to treat this block of ground each time he encounters it, than having, you know, these long strips of ground and having to reprogram new code each time you make a new level with, like, you know, a new piece of ground. In coding, you have to break things down to their smallest parts and then construct things out of the smallest building blocks possible. Literally, in our case, building blocks this time. Alright, let's take that one away. Okay, so what we need to do is we need to start making clones. So we've got our platform block selected. Let's go up to events. Let's grab a when green flag clicked. Oh, welcome to the Falcon Fab Lab CoderDojo. Lovely to see you here. Wonderful. All right. So what we're going to do now is we're going to make a forever block, a forever loop. And in this forever loop, we're going to get a repeat 10 times, and then we're going to create a clone. Okay. And then what we're going to do is we're going to get a piece of code that says what happens when I start as clone. So what we're going to do is we're going to have this platform here. Now this original sprite is going to be like the mothership that creates all of its clones, and it's going to move up and down and create a bunch of clones of itself that are going to move across like that. Okay? So what we need to do is we need to give the clones some instructions for what happens when they are created. So we're going to get a forever, and we're going to make the clones move towards the left. So let's get a change x by, let's try -5. So let's see what that looks like. Let's hit go. Okay. So it's making some platforms there. They're a bit too close together. So what we're going to do is we're going to put a wait in there. Now wait 1 second is probably going to be too long. So we're going to say 0.1 seconds. No, kitten? Well, as you can see, Jane wants to be part of the CoderDojo. He can be our resident ninja cat. Down we go. Alright. So let's see, so hit the red stop button and then hit the green flag. See, that's a bit better, but actually let's make it 0.2 seconds. Okay, that's looking pretty reasonable. Now watch what happens after a certain point. It's making all these clones, the clones are all moving, and then after a certain point it should just stop. You might have noticed this before, or if you're running your own game. Oh, thank you so much, Catherine. Much appreciated. Mine's still going, which is pretty impressive. It's still making its clones. But eventually what will happen is it will create too many clones and then it will refuse to make any more clones. It's not strictly a crash. A crash would be what happens if your game kept making new clones until eventually there'd be so many clones your computer just couldn't keep track of them. So what we need to do, you see, it stopped making clones. I think there's a limit of 300 clones, I think, per Scratch game at any one point in time. So what we need to do is we need to kill our clones. So we need to put in some kill code so that when the clones get far enough to the left, they die. They remove themselves from the game. Alright, so let's go to Control. Let's grab delete this clone. So what we need to do now is we need to ask a question. We need to get an if-then statement just up here in the control section. And the question that we need to ask is, have I reached the left side of the screen? Now, do you remember when I was explaining earlier about coordinates? Coordinates keep track of where a sprite is on the screen. So across here, I think is about 240. Yes. So you can see here, now that I've moved the mama sprite who makes all her clones across to the left, you can see the X value is like -248. I don't think it will go any further left than that. I think it refuses. So, and now if we want to kill all these clones just for now, we need to hit stop and they'll all disappear. But we need our clones to die during the game as well, not just when we stop the game. So let's get this if statement. Let's put it directly under the change x by -5. And then let's grab this here. Now, from memory, I believe, yes, we can do it that way. Excellent. From memory, we can go to motion here. And we can get this X position. So this X position here is wherever the clone currently is in terms of its X value. So how far left or right is it? Okay? So we'll grab this here. And so the way that minus numbers work, if you haven't covered this in maths yet, is so because they're negative numbers, if we had like 240 and I said, what is 230 less than 240? You'd say, yeah, 230 is less than 240. But if we're dealing with minus numbers, then 240 is less than 230. If you haven't covered it in maths yet, it's a little complicated. It might be a bit hard to wrap your head around, but just remember, with minus numbers, pretty much everything's reversed. So just take my word for it. We're going to ask the question, is the x position of this platform sprite, this one little block, is this less than 245? In fact, 248. Let's see what happens when we put that in there. So this is a question that's going to be asked every time the platform moves to the left by -5. It's going to ask the question, is the x position of this platform sprite less than 200... oh wait, I'm doing it wrong. I've done it wrong. Ah, see, I was testing you, you see, I was testing you. Minus 258. In fact, let's say minus 248. Let's try that. Let's see if it works. So we'll move this over here, and we'll see. Now, do these clones delete themselves? They do. They go off the screen. Oh wait, that one didn't. So let's make sure that it's minus 245. Let's make it like that. Now, I don't know if you can see this, but they're disappearing a little bit early. So I'll try and make that negative 246. That's looking pretty reasonable. Let's try minus 247. See if they still delete. That might be good enough. That seems reasonable. Okay, so we've got our clones being spawned, and we've got our clones deleting themselves, so we don't crash our game. What we need to do now is we need to move around our mothership sprite, the platform sprite that's going to be spawning all these clones of itself. So what we're going to do is we're going to grab, let's see, a go-to. So go to X and go to Y. That's this line of code that I'm wiggling here, and I've already shown you how to use that. We're going to make the sprite do what I've been doing so far with the mouse by itself. It's going to move up and down at various points to create all these different platforms that we can jump off of. So we already have this. This here, which is the code to create these sprites, and this is already in a forever loop. So let's put this code here, and you can see it moved just then, but it moved somewhere we don't want it to move. So where do we want it to be? We always want it to be on the right side. So how far right can we go? Let's go 250. Now can we go 255? Does it actually move any further right? Maybe not, but that's okay. So what we want it to change each time it moves is its Y position. So now we're going to introduce a little chaos. We need to get a random number. So we're going to grab this, pick random, 1 to 10. Now, that's not enough chaos for us. We need more chaos than just between 1 and 10. Let's try between minus 100 and 100. And we're going to take this here, this pick random, and we're going to put it right here where the Y value is. And now, what we should be seeing is this sprite moving around and creating all of these different platforms. So once we have this working, should be able to jump between all these different platforms. So what we need to do now, and so these numbers can be changed later, because if we find that it's going a bit too high, then we can bring this number here, 100, which is the highest point that it can go to on that y-axis. So we can bring that down a little bit. Let's try minus 100. Let's try minus 120 to 80. And now you can change this yourself. You can fiddle with these numbers, and remember the y point of where it's going is the up and down axis of where this sprite is going. Okay, so what we're going to do now is we are going to do something that just makes the game look a little better. So we can actually still see our original platform sprite that's spawning all of these clones, can't we? We can see it there, and it looks a little weird. So what we're going to do is we're going to make our original sprite hidden, so it cannot be seen. So when the game starts, we're going to hide the original sprite. Now here's a problem. Every clone that it makes will also be hidden. So we need to add a show in right here. This is all in the looks tab right here. We grab this show and we put it right here, just after when I start as clone. So now what we have is these blocks that look like they're coming out of nowhere, which is good. That's kind of what we want. We want them to appear off screen and enter on screen. Okay, good. Making progress. So this block of code here will run over and over and over and over again. And you've got to think about, and this repeat here will dictate how long these platforms, these long platforms are. So if we were to change this repeat to 2, what does that do? Now I've got all these little platforms. We change this to 1. Now I've got all these individual platforms. We were to change this to 20. Now I've got very long platforms. So there's a few interesting things we can do with this. We can go to operators and grab ourselves some more chaos. Let's get a pick random. And let's put it right over the repeat function. And 1 to 10 might be a little too extreme. I'm going to make it 3 to 10. And now one other thing I'm going to do is, can you see how some of these platforms, well, they always are directly next to each other, which I'd like some pits in between these platforms. I want to have something that I can fall down. So let's create a wait. Let's grab a wait 1 second. Let's grab that, and we want this wait to be directly here. And let's see. Ooh, those are very, very wide gaps. Maybe we don't want a gap to be that long. So what do we change? Scream it at the monitor. I promise you I will hear you. Yes, you're right. Quite right. I'm going to change the amount of time that we wait. 0.5. We're going to wait a shorter period of time and tighten up these gaps. Okay, that seems good. Now, when we actually start to develop how high our character can jump, that will again change. We'll want to fiddle with these numbers a bit more. because we might find that it's a bit too high for our character to jump, depending on how we code the jumping. Okay, so we've got our platforms working. I'm going to make the gap a little bit shorter, 0.3. 0.4 then. Final answer. You can always come back and change this later. Okay, that's good. I'm going to do one more thing. I'm going to change this wait 0.2 seconds into 0.25. See what that does. The blocks are a little less on top of each other now. So all these numbers, you can tweak them. Have a play with them. Like look at them, go, it says 0.25 now. What happens if I change that to 0.3? What happens there? Oh, now I have these little gaps. If you like that, then you can keep that, no problems. I'm going to go 0.27. No, that's still got gaps. I'm going to try and go for gapless. 0.26. That looks good. I'm happy with that. Cool. Alright, so let's go stop. So our player. We've got gravity working all the time on the player, and we need to check for something now. We need to check, we need to make another if statement. So we need to go to control, we need to get this if statement here because we're going to ask a question. Because how does gravity work? If you're standing on the floor, can you keep falling through the floor? No. The floor holds you up. We want our platforms to hold the character up. So in video game design, this is called collision. The idea that two objects, when they touch each other, will not be able to pass through each other. They will be able to detect that they are touching each other. And if you see games go wrong and glitches, you'll see sometimes when collision goes wrong, you'll just have these objects just pass through each other like ghosts, and that completely ruins the sense of immersion from the game. We don't like that. Okay, so although being able to turn off collision to create things like ghost mechanics could be interesting for a different type of game. So let's create some collision, shall we? We have to ask a question. And the question that we're asking is, am I touching something? So we'll grab this here. Touching mouse pointer. We're going to grab this, and can you see that this is sort of like a, like a hexagon shape, right? 6 sides, hexagon. Like I often describe it as like a jewel shape or a diamond shape. Not actually a diamond shape. But anyway, and you can see that this is the same shape here. This can go inside here, like that. And we want to ask the player, is the player touching a platform? And if they are, we want to make them move backwards. Now, there's a few different ways to do this. And we're going to have a bit of an explore of them together. But this is a nice simple way. So computers work very, very quickly. Coding runs very, very fast. You can ask this type of question, are you touching a platform? If you are, do this thing. And you, the player, may not even see it happen. So what we're going to ask is, so this piece of code here is, it starts when the game starts. It happens forever, over and over and over again, that the character moves down by 5 pixels. That's what so that -5 is it moves down by 5 pixels. And if you're touching a platform, then move up by 5 pixels. Let's see what effect we have. We might have this sort of quivery effect. I'm hoping not, but we'll see. Let's drag you up here. Okay. Yeah, so your character kind of now just sort of nicely hovers. Now there are better ways of doing this, and if you'd like to mention them, it'd be great to get some participation, and we can think of better ways of coding this. I'm looking forward to you guys sharing your code with me in the comments, being able to maybe publish your projects on Scratch, and I can look them up and we can sort of collaborate together. Whoop, there we go. So, we've got our gravity working and we have our collision working. Relatively simple. A little hacky probably, but relatively simple. We need to make our jump work. So, so if we start again, there we go. Now, there's a problem. And that's we can jump all the time. I can just hold this down. Also, the jump isn't working super well, like the character's rising very slowly. So let's tackle this one thing at a time. Let's change the jump by a dramatic amount. Change Y by 15. Okay, so the jump's looking a little bit better now. The falling's a little bit floaty though, so let's increase gravity a little bit. Make this a little bit. Increase all these numbers. So now this is the gravity where you're falling by minus 10 pixels. If you touch the platform, you do the opposite, you go back up by 10 pixels. And then the jump here, when the space key is pressed, you repeat 10 times change Y by 25. So, let's try this. There we go. So this feels pretty good. But now I feel like the platforms are moving a little bit too slow. So let's go across to the platform sprite here. And let's try and increase the speed of these. Now, once I increase the speed, because this is a relatively simple, somewhat hacky programming that we're using, it's going to create those gaps again. So let's see what... that seems pretty good. Oh. Now, here's something that's a problem. We can jump even though we're not standing on anything. Alright, we'll handle that in a second actually. First, let me get rid of these gaps. Let's try that. Alright, let's try that. Alright, let's try 0.11 right here in this weight here. Oh, no, still got a gap. Let's try 0.1. Alright, let's change the speed down to -9. So all of this, changing the speed and such, you can make a very different type of game if you want. You can sort of change these numbers remember, this is the speed here at which the platforms move. This is the gap between each platform. So if the platforms move faster, they're going to end up stretching out a little bit. So you can bring that in a little bit. It's looking pretty interesting. Oh. But we have one problem. We can jump even if we're not on a platform. So we can essentially fly, because the code doesn't check to see, you know, if we're allowed to jump or not. So there's a simple way of fixing this. We need to create a variable. And the variable is down here. So on the left side, this sort of dark orange category here. Oh, thank you very much, Quentin. Much appreciated. We're going to create a new variable. So there's a button here, just where it says make a variable. We're going to call this variable CanJump ? And we're going to make it for all sprites. So now we have this little variable up here. And we only need to set this variable to one of two possible values. Yes or no, or true or false, which, and this isn't something that you necessarily need to know for Scratch, is a Boolean type of variable, and it's very important when you move on to things like Python, C+, and that kind of thing, other coding languages. So we need to change this variable to, we need to set this variable if we touch a platform to true, or you can put yes if you want. So we're going to set CanJump to true, and then what we need to do is we need to add in another if statement, which grab this if here. And what we're going to do is we're going to grab this repeat here. We're going to put it inside the if. Then we're going to take the if and put it here. So do you remember what this code does in our player sprite? This code is the code that makes us jump when we press space. So now, before it jumps, we need to ask a question. The question is CanJump true? So we need to go here to operators, and we need this here. So something equals something. I'm going to grab that, I'm going to put it in the little slot that's made just for it. Then we're going to go back to variables here, and this little round CanJump ? Variable, we're going to grab that and we're going to put that there. And then the question we're going to ask, if CanJump equals true, so is CanJump equals true, then we need to immediately set CanJump to false. Alright, let's see how that goes. So now I can't jump unless I'm touching a platform. You can see I can't jump in the air anymore. So that's a really simple way of checking to see if your character is able to sail through the air, not able to jump off of nothing. They've got to have reset their can jump variable back to true. And when does that happen? It happens once they touch a platform. So it's a very nice, simple way of having a way of making your character only able to jump when they're touching a platform. Or, yeah, once they've touched a platform. Okay, so what we're going to do now? Let's see. Well, we've got... we need a starting position. So what we'll do is we need our player to start maybe here. That seems good. So we can see the coordinates of where our player is. We've got the coordinates are minus 179 in X and 125 in Y. So let's go and grab this in motion. We're going to get go to X equals minus 179 and Y equals 125. We're going to grab that and we're going to make the player, when the game starts, no matter where they are, no matter where you left them when you were last playing the game, they're going to move back up to here. Okay, so that's good. The player always starts up there, but there's a problem though, isn't there? The player still falls too fast. So what we should do is we should create some kind of countdown. So let's put a wait for 3 seconds. In fact, no, 3 seconds. Okay. So now, there we go. It waits for 3 seconds, and then it drops you. Let's try that again. Let's see if it drops us into a pit. No, seems to be okay. Let's try that again. Drops us into a pit. Not quite. Now, some of you have probably noticed we have a bit of a glitch. We can get stuck. Well, not get stuck. We can kind of get nicely lodged in the side of one of our platforms, which sort of saves us. We can look into how to fix that maybe later if you guys want to improve your endless runner game. There's another thing that we need to do. This variable, the player doesn't need to see it, so we're going to make it hidden, this can jump question mark variable. So let's go across to the left side of our screen to variables, and let's untick right next to where it says can jump. And now it's nice and clean. Okay. So we nearly fell down the pit there. So the reason that we nearly fell down the pit is because the platforms are being generated with these random little gaps in them, which is fine when we're playing the game, but a bit of a problem at the beginning when you're waiting suspended for the game to drop you. So let's start off with a nice long stream of clones for us to fall into. So let's grab this repeat here. So right click this where it says repeat and then press duplicate. Let's put this over here. So this code here, this is the code that creates all of those little platform blocks. So what we're going to do, we don't need this wait. Oh no, we'll keep the wait, why not? But we don't need this pick random. Let's grab this pick random block here and repeat 20. That seems pretty safe. If we repeat 20 times, that will equal about 2 seconds. Oh, that's not enough time then. Let's go, because we wait 3 seconds and then we get dropped. Although there will be a delay as the platformers move across. Let's still say 30. So let's grab this, and we'll put the whole thing just underneath the hide before the forever. So it's going to make a nice long line of those blocks for us to land on in our endless runner game. There we go, very nice long line. And then the game starts. That seems reasonable. Alright, let's do something a bit fun. Let's make a countdown timer. So let's go to sprite paint, and let's create a 3, 2, 1, go style graphic that comes up as your game starts. So to do that nice and simply, what? Nearly ducked aside there. Okay, so to do this nice and simply, we're going to grab this text here. And what color shall we do? Let's do it in red. That seems reasonable, like that. So let's put a nice big 3. I want it bigger than that. Let's change it nice and big like this. Nice and in the center like this. Okay. And what we're going to do is we're going to use this sprite, and it's going to have multiple costumes. So if you think about, let's say, a Mario game, and Mario's running, the Mario sprite is moving, so it looks like he is running. His little legs are moving, his little arms are moving, his little head's moving from side to side. But it's still the same Mario sprite. It's just changing how it looks. And so that's the essence of how animation works when you're using sprites. So what we're going to do is we're going to make multiple frames of animation here. So we're going to give this costume a name. We're going to call it 3. Now let's right click on the 3 over here and let's duplicate it. And let's see, once we've duplicated the 3, yeah, we can just change it to a 2. Let's duplicate our 2, call it 1 up there, click there, type in 1 there, let's duplicate again and say go, and let's grab this and put it right in the middle. These are the ones in the middle. Yep, that's in the middle. Yep, that's in the middle. Yep, that's in the middle. Excellent. Okay. 3, 2, 1, go. Nice. So, what we need is we need that to animate through our 4 different costumes, and then we need it to disappear. So, we need this to happen when exactly? At the beginning of the game. So let's go to events, let's get a when the green flag clicked. Let's get a looks. Now what we need is something called show, which we've used already with our platforms. And you're thinking, why does it need to show? It's not hidden yet. Ah, you will see, because we need to hide it later. And if it hides at the end of the first time we play the game, we need to make sure it shows itself when we begin the next game. So we're thinking ahead. So when the game starts, when the green flag is clicked, we show. We also want to make sure that this is in the middle of the screen. So what I'm going to do is I'm actually going to get this line of code here, go to, and do you remember what the very middle of the screen is, both in X and Y? 0 and 0. I hope you've been screaming it at your TV monitor, at your computer monitor, I should say. I promise you I can hear you. Alright, go to X 0 and Y 0. Good, good, good. Then we're going to show, and then we need to change the costumes that we're on. So we're going to grab switch costume to 3. Oh, let's quickly let's go back to this. So let's give this a name. We shouldn't be calling it sprite 1 for one thing. So just over here on the right, just here, let's call this our countdown. Then let's go across to costumes, and can you see the names of these costumes is 3, 2, 1, 4. That's a bit confusing. Let's rename our Go costume up here to Go. Nice. Yeah, we're going to go back to our code. Very good. Okay, so we switch. So when the game starts, we go to X equals 0, Y equals 0. We show to make sure that we can see our countdown. Then we switch our costume to 3. Then what we're going to do is we're going to go next costume, and we're going to do that 3 times. So I could just go next costume, next costume, next costume, and then put in the weights. But that's really inefficient. Instead of doing that, let's get a repeat. It's not too bad if you ask something to happen 3 times, but just imagine you wanted something to happen 10 times and you typed it out or dragged it across 10 times. It's really inefficient. If you want the same thing to happen or something very similar to happen, you should always try and use a repeat. It's much more efficient. Okay, so we've got our repeat 3. We want to go, first we're going to put the weight 1 second, then we're going to go next costume. So let's see what that does. So we can hit go, 3, 2, 1, go. Now we have a problem. The go is still there and it's in the way. So we need to hide at the end of this. But before we hide, I'm going to show you something kind of interesting. We're going to do a graphical effect. We're going to get another repeat. We're going to set it to repeat 10. We're going to go to looks, and we're going to change. Actually, let's no, change. So currently it's set to change color effect by 25. There are a few different effects you can use, and these are actually very useful. The one that I really like is called the ghost effect. I also quite like the brightness effect. So I'm going to take the ghost effect. Now these effects are like a percentage, I'm pretty sure. So if you make something 100% ghosted, it disappears entirely. So because we're doing this 10 times, I want to change the ghost effect by 10, because 10 times 10 is 100. And then we're going to hide. So let's see what this does. 3, 2, 1, go. And it fades out, but it was a bit quick. So if we want it to happen a little slower so that we can actually see the graphical effect, let's put a little weight in there here. Weight let's say 1 second, 0.1 seconds. Right here, so the repeat is repeat 10, change ghost effect by 10, then wait 0.1 seconds before you change the ghost effect by 10 again, and 10 again, and 10 again, and this change, ghost effect by 10, means that it's increasing the ghost effect. It's adding 10 to the ghost effect, then adding another 10 to the ghost effect, then adding another 10 to the ghost effect, and as the number gets higher, the ghost effect becomes stronger. 3, 2, 1, go! And then it fades out. And that happened a little slowly, I think. So let's make that 0.03 go. That's pretty good. Can we even make it a little bit slower than that? So let's change the weight to 0.04. 3, 2, 1, go. Do you know what? I think I like 3 better. A lot of coding is this. It's kind of experimentation. One thing that's very important if you're doing tutorials, especially if you have a written tutorial, is that each time you add something in, little things, test it to see what it does. Because if you do like the entire tutorial but you never test it once, and then at the end you hit go and something doesn't work, you don't know which bit didn't work. When you're coding, you should always add small parts to the code. Test it, see how it works, then add another small part, test it, see how it works. So it's early days with the live streams, but I'm hoping what can happen in the future is that if you're doing these from home and you're tuned in live with me, you can be in the chat and say, oh, Jonathan, this isn't working for me. And I can be like, oh, okay, well, show me your code. Try and publish it on Scratch if you have a Scratch account. Maybe take a screenshot and email it to me. Or you might even be able to post a picture in the chat, and I can look at it and go, I see what you're missing. You're missing the weight. This is what you need to do. So hopefully we can get some nice collaboration going. All right. So we've got our 3, 2, 1, go. There we go. Oh, dead. I jumped too early. Now, one more thing we need to do is make a way for us to die. So what we'll do is, in fact, we can even use our countdown sprite to create a game over. Let's go to costumes. Should we do that though? Yeah, we'll do it this way. Let's copy the go. Let's call it game over. Let's see, can I can, good. Game over. Oh, goodness. Game over. Let's make this smaller. There we go. Add an exclamation mark just to troll our player. Why not? Let's do that. So, got our game over. Let's go back to the code. So what we're going to do is we're going to go to player, because we need to make a way for our player to check if they have touched the bottom of the screen and thus died. So we have already here this if question. If touching platform, then set can jump to true and change y by 10. The set can jump to true is what enables us to jump again, so that we're not able to jump in midair. And the change y by 10 is what prevents us from sinking through the platforms. It's counteracting the change y by -10. Okay, what we're going to do is we're going to right click this touching platform, this if here, and we're going to duplicate, and we're going to pop it here, and we're going to change this second if statement. We're going to say, we're going to grab out this touching, and what we're going to do is we're going to do something very similar to what we did with our platforms. So do you remember how with our platform code, we have it checked to see if it's on the left of the screen, and if it is, then it deletes itself. Well, our player isn't a clone, so it can't delete itself quite in the same way, but we're going to do something very similar. So we're going to go to motion, the dark blue section of code. We're going to ask a question about Y position. We're going to go to operators, the green section, and we're going to get a less than. So this is one of the things that's a bit tricky. Can you see we've got two different codes, two different lines of code. There's a something greater than 50 and a something less than 50, and then a something equals 50 over here on the left side. The less than is this one here. It's very important you get them the right way around. If something's not working in your code, double check. There's a few different ways of remembering the difference between greater than and less than. The one that I find easy to remember is that the narrowest part of the arrow is pointing at the lower thing, the lower number, let's say. The lower number, less than. So we've got is Y position less than, let's say, minus 180. Let's grab that, put that there. We can grab this set can jump to true away, and this change Y by 10, we don't need that. So now if Y position is less than minus 180, then what we need to do is we need to do two things. We need to first hide so that our player looks like they fell off the bottom of the world and died. Now, because we put this hide in, that means that when we start the next game, we'll still be hidden. So we've got to remember to get this show and put it at the very top. So that at the beginning of the game we show, and then if we die, we hide. And then we need to do one more thing. We need to broadcast a message. I'm going to grab this broadcast, and we're going to put it right about here. Yes, inside the if statement. And we're going to give this message a name, because make sure that you name everything in your code, because if you have a sprite called sprite1 or a background called background3 or a message called message4, you'll be like, oh no, what does that message do again, when you're trying to figure out when you want to change something or when you want to improve something. Okay, we're going to give this a new message name. The new message name is Game Over. Alright, and now what we need is we need some code inside our countdown sprite that responds to Game Over, because this broadcast doesn't mean anything unless the sprites that receive the broadcast know what it means. So basically a broadcast is like a message that gets sent out to all the different elements of the code, but you need to have some code that explains what a sprite should do when it receives that message. So that's what we're going to do. Game Over. I'm going to go across to here, or rather the countdown sprite. which is kind of being used for double duty. We're going to grab when I receive game over. So when I receive game over, what we want to do is we want to show. Now this ghost effect will still be in place, so we need to clear that graphical effect like this, and then we need to switch costume to game over. In fact, let's do that at the beginning. Switch costume to game over, show this sprite, clear the graphic effects, and let's see what happens there. 3, 2, 1. If I fall down, game over. And if that happens a little too quick, we could even create a little pause in there. Let's say 0.2 seconds. 3, 2, 1, go. Something interesting happened there. 3, 2, 1, go. Let's fall down. Let's remove that weight. 3, 2, 1, go. Game over. So what I think might have been happening, where if we die really early on, it might still be figuring out its ghost code. Seems to be working okay now. Well, that's fine, no problems. We've got our game over screen. Okay, so now there's only one thing left to do, and that's to create a score and a high score system so that people can get competitive and see how long they can survive. So let's go to variables, and where should we put this? Let's put this in the player. So click across to your player, let's create a variable, call it score, and as we're running out of time I might do the high score on a different day, but high scores are pretty common, we'll cover them when we cover other games. Let's get this to change. So we've used set before. Set a variable overwrites whatever that variable was before. If it was true and we say set can jump to false, now it says false. The true is gone. Change score, on the other hand, takes what you already have and modifies it. So if your score is 1 and you change the score by 1, it goes 1 plus 1 and your score becomes 2. If you change score by -1 and your score was 9, then it goes 9 minus 1 equals 8. So this is kind of useful, being able to modify a variable rather than just completely overwrite it. So what we're going to do is we're going to create a forever loop. We want this forever loop to happen at the beginning of the game. So we want when green flag clicked from events, then we want forever from control, change score by 1, and then let's put a weight in there. So it's ticking up 1 second at a time. And we also need to, at the beginning of the game, set score to 0. So now when we start the game, 3, 2, 1, go. And our score is ticking up now. And you know what? We might have time for a high score. Oh. Okay. So if we want to create a high score, there's a fairly simple way of doing it. We need to ask a question. And the question is the score greater than the high score? So let's make another high score variable. To do that, you go to Variables on the left, click Make a Variable, type in high score, and then we're going to get a set high score to the score. And then we need a high score over here and a score over here. So this is the piece of code we've just added here. If the score is a bigger number than the high score, what does that mean? That means you now have the high score. So then you need to set the high score to whatever the score is. So let's see if it works. So it's oddly, oh, I see, it's because the weight. Yes, let's put that, this weight here needs to go at the end. It was there, so they were sort of, you can see that the score is 8 but the high score is 7 because there's a gap between them of 1 second. So if we move this weight 1 second down to the bottom, that should fix that. Score. There we go. And now the high score is going up with the score, and if I start again, I've got to try and beat the high score again. And there's one really useful thing that we can do with the score, is you could actually use that number, as that number got higher, to increase the speed of your platforms. But that'll be one for another day. So I hope you found this interesting. If you have made the game at home, then please post a link to the, then publish it on Scratch and post a link to it. If you have any questions or if anything went wrong for you in this tutorial, especially if you're watching it later, maybe not live, then leave a comment and I'll come through and try and answer as many as I can. The CoderDojo from the City of Swan Library's Futures Lab, we will be running one of these every Monday, every Tuesday, and every Thursday until we decide to change up the schedule. So feel free to tune in tomorrow. Tomorrow we're going to make an avoidance game, like a dodge game, and that should be a lot of fun. Tell your friends. You can all come on together and do some coding together. Even if you just want to hang out, not necessarily work off of the tutorial that I'm giving you, but just meet up with some of your fellow ninjas. You guys take care, look after yourselves, and hopefully I'll see you tomorrow. Oh, yes, do you want to see the platform code? 1 second. Okay. I've got to remember about this delay. Okay, Falcon Fab Lab CoderDojo. Platform code. Here you go. going to have to remember about this delay. When I ask a question, I'm going to have to wait a little while until I get an answer. But yes, did you run into any problems, Falcon? Any little issues with the code? Otherwise? Aha! Yes, the hide show. There we go. Is that all working a bit better now then? So yeah, I think it's going to be about a 30-second delay. I wish I could make it shorter, but we'll have to see. Oh. Excellent. Glad to hear it, Falcon. Well, if you're on the Scratch online version, feel free to post the link for the Scratch project into the comments. Oh, I died. And what I'll try and do tomorrow is I'll sort of set aside the last 15 minutes maybe for sort of troubleshooting. During the tutorial, feel free, if you're like, oh, could you just go over this for us? Feel free to. Oh, wonderful. I'll send our ninjas your way. That's great. That's fantastic. Yeah, I'm really looking forward to doing these. And I think it'll be really nice. Keep the CoderDojo soldiers on. Keep all of our ninjas connected, and make some games along the way. Once we have a bit more of a routine, what I'd really like to do is work on some longer form projects. For the time being, I'm going to try and keep all of our projects to single session game, more or less complete by the end of. I think that'll be a lot of fun. And if you have any particular requests for games that you'd like us to make together on stream, that'd be great. Maybe we can do some voting for like what our next project can be and that kind of thing. I think that should be a lot of fun. Yeah. Overall, I'm looking forward to keeping our CoderDojos going, moving them all online. All right. Well, the other thing as well is if you want to contact me specifically, the best way to get to me is my email address. Just up there on the screen. Hopefully that comes out big enough. So feel free to contact me through here if you run into any problems with any of the projects. Just send me a link to the project. If you can publish it on the Scratch website, I'll be able to take a look at it and we can figure out what the issue is. And if you want to think of some improvements that we can make, that'd be pretty awesome as well. Yeah. Aside from that, I'll make sure I leave some extra time at the end for us to have a bit of a chat. But apart from that, I'll see you guys tomorrow. Same time, same channel, 3:30 onwards. If you... Oh no, I sound like a horrendous YouTuber now. But if you subscribe and click the bell... Oh, I feel dirty saying that. If you subscribe and click the bell, it will give you notifications when I'm doing more live streams. And we've got bigger plans as well. We'd like to do maybe some gaming events, some other technology stuff, not necessarily just Scratch, maybe some art stuff, maybe some music programs as well, some music projects. So yeah, sky's the limit. Anyway, we'll see you guys tomorrow. You take care of yourself, and we'll see you then.